So before we can have a deep discussion about Copilot for security, it might be a good idea to establish a baseline understanding of generative AI itself. Let's take a few minutes in this session to do that and look at the fundamentals of generative AI. What we want to do is by the end of this module, we want to have an understanding of AI's place in artificial intelligence, the language models that we'll use, and services that we use to generate original content based on natural language input. You learn about the role of generative AI in creating AI-powered copilots that assist us in common tasks. All right, so by definition, generative AI is a subset of artificial intelligence where a model creates original content in response to natural language prompts. That's a mouthful. What we mean is that you could talk to AI like you talk to your coworker, and it'll understand and translate into the creation of content. For example, you can ask it to write a cover letter, create a logo, or generate Python code. Let's take a moment to see generative AI in action. So watch as I generate a simple Python code snippet using a natural language prompt. I don't need any specific language. I don't need any specific format. I can just simply ask Copilot, hey, can you create Python code to connect my database to the internet? And you notice I have typos even in this prompt. Copilot is smart enough that it can figure out in context what I actually meant and give me the kind of response I would expect. So watch this in action. It's going to take that simple declarative sentence and author original code from that. I don't need an extensive background in Python. It'll help me troubleshoot whether or not the code is accurate. But this empowers anyone to be able to leverage the power of artificial intelligence to generate original content. And that's what generative AI is all about. Okay. So the engine behind this are large language models, or LLMs. These are specialized machine learning modules used for natural language processing tasks. These modules can determine sentiment, summarize text, compare multiple text sources, and generate new natural language. We can look at these large language models as a type of transformer model. What a transformer model does is it's trained with large volumes of text. So think about being able to feed examples of all kinds of words. And what the large language model does is it uses something called an encoder-decoder architecture. Really what we're doing is we're trying to create a semantic representation of vocabulary and generate new language sequences based on that vocabulary. That sounds really technical. But what it does is this is what allows the architecture to understand human-like text, where it's able to understand what a dog is because it sees a dog in relationship to other things. It's able to understand the difference between a dog and a cat, yet understand that those are kinds of animals and distinguish that separately from a skateboard or a house or a car. If we use a large enough volume of text in training the model, we can create multiple relationships between words and generate output very close to human responses. I used the phrase training the model a moment ago. The first step in training a model is tokenization. This is where training text is decomposed into tokens. Each token is assigned a numeric ID. This helps the model understand the relationship between words and generate coherent text. If you think about the more words the model is trained on, the more tokens it can generate, which means the potential combinations can grow at a rapid rate. The relationships between tokens are what we call vectors. Vectors can be described in data science terms as embeddings. Think of it like this. Having tokens means we know a word, but without understanding how the word relates to other words, we can't extract meaning. Vectors give us a relationship between words. These embeddings help the model understand the semantic relationships between words, enabling it to generate contextually appropriate responses. In the example you see here, dog and puppy exist in the same vector. Cat is on a different but similar directional vector, but skateboard is in a completely different vector and direction. This is a very simple representation, but it helps convey the basic idea of how large language models work. But that still doesn't ascribe this ability to process sentiment and content. As you go further into understanding large language models, attention layers are what help these transformers capture that relationship between those tokens, and more importantly, the strength of the relationship between them. This technique helps the model focus on relevant parts of input text, improving the quality of the generated responses it gives. This isn't the only layering that goes on into this, but it gives us an illustration of how the underlying technology helps us process our prompts into the generative output we see. Now, we could develop our own models on this line. If we have the time and resources to commit to this, we could build large, robust AI solutions tailored to our own specific interests. For the vast majority of us, though, it's more effective to use existing what we call foundational models and fine-tune them using the data that already exists in these libraries. Services like Azure OpenAI Service has trained models from OpenAI. Model catalogs can contain external sources like ChatGPT, DALL-E, Mistral. All these models are pre-trained on large data sets, but still have the ability to be fine-tuned for specific tasks. They give us a strong starting point for building generative AI applications and allow us to save time and resources that we'd have to devote to training them ourselves. The foundation we build in Copilot for Security is rooted in the fundamental AI design that encompasses all of the Copilot ecosystem. We can take this platform and turn its natural language-driven powerful analysis towards a complex world like cybersecurity. This brings the question then, what are copilots? All right. Copilots are the outgrowth of these language models. Large language models, like we talked about, work on larger sets of data. Small language models can be specified on smaller subsets of data. And this is where copilots can kind of help build. Because what copilots do is they help us use generative AI with sort of like a pre-trained assistant. Those assistants can be accessed individually, or they can be integrated into applications. You probably see these most common as chat interfaces within the tools that you're already using. They're able to provide contextual assistance with the everyday tasks you use this for, whether you're using them in M365 applications like Word and PowerPoint, or we're going to focus on security-related tools when we're looking in our extended detection and response tools, or whether we're looking in our information event management tools. Business users can use copilots to produce their connectivity, and security analysts can use it to help resolve complex data sets quickly and effectively. This gives us that ability to extend what copilots do to tailor their needs specific to the task that we have associated with them. Not only that, developers can extend copilots by creating plugins that integrate them into business processes or data, or even create custom copilots that build generative AI solutions into apps and services. Copilots are designed to get us past the initial parts of a task faster. They don't replace us, but they act as a highly skilled assistant that can grind through the first pass or rough draft and let us use our talents more effectively and more efficiently. So what are some of the copilots that we might find in our ecosystem? Well, we've got AI on the web for browsers. We've got AI in Microsoft 365. We have AI or Copilot in Word, Excel, PowerPoint. So you can create presentations, generate documents, summarize emails in Outlook or Teams. You can use Copilot to analyze support tickets. You can use it to generate code for data analysis and visualization. You can use it to generate code snippets and provide code documentation by using it with services like GitHub. But specifically, what we talk about is how we can use it to consume information in natural language when we're talking about security. In our introduction, we talked about how the number and volume of signaling that comes into our environments is massive. What we want to be able to do is, in an easy, conversational, natural language way, be able to get insights into what that security signaling means. That's what Copilot does. Now, how can we get the best results from that? Copilot is only as effective as how we interface with it. So a large part of what this entails is crafting effective prompts. An effective prompt should always have 4 key elements associated with it. Number 1, start with a specific goal. What is it you want Copilot to do? Second, provide a source. That source information will help ground the response in a specific scope. Third, add context. Context helps the responsiveness. It allows Copilot to provide appropriate responses quicker. Without context, our responses can often be vague. This context helps take the source information with the goals that we specified and give relevant answers quickly. And then lastly, set clear expectations for the response. This is not necessarily going to be a one-off process. We're going to have to iterate on the previous attempts that we use. And that's a real power of Copilot. Copilot understands context. So if your first answer didn't give you what you wanted, you could tell Copilot, that's good, but can we format the answer this way? Or can I limit the responses to only this part of the information that I've shared from you, my source? That iterative effect allows you to ultimately land at a goal that's effective for you. So let's see what an effective prompt looks like and how effective prompting can be used to create appropriate response. So what does that look like in practice? So as we said, we should start with a goal, okay? Let's see, how about write a 3 to 5 bulleted list, okay? So now I have a very specific goal. I've told it what I want Copilot to do, all right? From the marketing strategy document, okay? And then I could specify there what my source is and even add that document to the list, all right? Now, context, all right? Using the section on product specifications, okay? Now I've got context for what I want it to have. And then I can say, in a professional tone. Okay. That's an example. I've set those 4 elements there as part of a prompt. And now I can give that prompt to Copilot if I was using Word or PowerPoint and have it build or extend that prompt into actual content that I want to use in the environment. All right. Copilot is not just limited to the language models and services that are extended to it from within the Microsoft ecosystem. One of the cool things that Microsoft does is it provides you tools to allow you to extend and develop your own Copilots. Copilot Studio is a low-code development asset that allows you to create Copilots and plugins using Azure OpenAI models for generative AI. Azure AI Studio provides a platform for developers to fine-tune models with their own data and deploy custom copilots. These tools enable organizations to create tailored AI solutions to integrate seamlessly with their existing workflows. That's kind of the big picture of what AI can do. As I said, we want to ground our discussion in Copilot for security in, first of all, what AI can do and what the Copilot ecosystem at Microsoft can do. So let's do a quick little knowledge check to see how well you understood some of the things that we talked about here. So real quick, first question, what are large language models? Models that only work with one language, models that only work for small amounts of data, models that that use deep learning to process and understand natural language on a massive scale. I'll pause while you think of your answer. And it's the last one. Large language models are models that use deep learning to process and understand natural language on a massive scale. Let's try another one. What's an example of a potential task a generative AI application can help solve? Monitoring the temperature in a manufacturing facility, creating a draft for an email, collecting real-time data and storing it in a database. I'll pause again while you think of your answer. Creating a draft of an email. One of the things that copilots do is they get us through that initial phase faster. So any initial iteration we want to use, that's a great opportunity for Copilot. Lastly, what's the potential impact of copilots? Copilots only impact applications used in professional settings. Copilots can help with first drafts, information synthesis, strategic planning, and much more. Or copilots can only be used for certain natural language tasks like summarizing text. Let's pause again while you think about that one. All right, copilots can help with first drafts, information synthesis, strategic planning, and much, much more. Copilots are an assistant. Think of all the time it takes you to go through the initial phase of any process. What we want to do is have that time return back to you so you can leverage your strategic talents further along in the process and get that initial part iterated through faster. Okay? So, this is a summary of what we looked at. We looked at what generative AI is, large language models, Azure OpenAI and copilots, and how to improve generative AI's responses with prompt engineering. I want to thank you for joining us on this journey through Copilot for Security. Stay tuned for more insights and practical application of this powerful tool. Until next time, stay secure.